Hello guys, welcome to another series of 2JZ Tuesday. My name is Michael Chong and today I'm going to show you guys how to dial your cams in. Okay guys, I'm going to show you guys the cam dialing on a whiteboard. This should be easier for you too. Okay, so the first one is you need to understand your degree wheel. Okay, for now I'm using this Lakota degree wheel. This one is from Taiwan. This one they have quite good quality, quite good finish too, and their price is very affordable, and I highly recommend them. I like to use their products, quite good. Okay, so the 0 is pointing the top dead center. That means the first piston is reaching the most top. Okay, so we call it the top dead center. So when this one turns, the piston will go down towards the bottom dead center. Okay, so this is the first thing that you know. Then the second thing is the crankshaft always rotates in a clockwise direction. Okay, this one is important because so that you can imagine what is happening inside the first piston, inside the cylinder. Alright. Then the third one is you need to know what is the A and B. Okay, after top dead center means like this. After this one is before bottom dead center. This one is after bottom dead center. This one is before bottom dead center. Okay, so this is we understand what all the annotation when we use the cam card. Alright. Okay, so the second thing is we go through your cam card. Okay, so I'm using the 2JZ non-VVTi Brian Crowell 264 cams. Okay, so this is the numbers that I get from the website. Okay, the intake cam is 0 degree after top dead center. Okay, let me mark the intake cam using the green color. Okay, so it is 0 degree after top dead center, or after or before, it is the same thing. Okay, so it is 0 degree is here. Okay, I just put IO. Okay, intake opening. Okay, close is 40 degrees after bottom dead center. That means it is the piston goes down, it sucks the air in. But after bottom dead center, where the piston going up, the air is still rushing in. It allows the momentum of the air to move in more air. With more air, more fuel, you get more power too. Alright, so 40 degrees after bottom dead center is around here. Okay, so this one is the intake closed IC. Alright. Okay, so we got this information. That one is not enough. What we need to do is we need to find one more thing. Right? The last thing is I call it the center line of the intake for this cam. Okay, so how do we do the center line? Okay, so the center line is denotes the maximum lift of the cam. Okay, the maximum lift. That means the middle, just the middle of the cam. Okay, so of the cam opening. Okay, I should say. So what we do is we total up this, the duration of the cam lift, and we find the middle. It is very easy. Okay, so it says 0 degrees, so it is just 0 until 180. It is 180. Okay, let me count here. 180 plus 40 degrees after bottom dead center, right? Just plus 40 equals to 220. Okay, so where is the middle of 220? It's just 110 after the bottom dead center, around here. This is the center line of the intake. Okay, that's all. So what we need to do is we need to run it up. Okay, it is 110 degrees after top dead center. Alright, so far are you guys following me? Okay, I'm going to explain a bit the exhaust. Okay, this one is slightly need a bit more imagination because the degree wheel that I'm having, okay, the degree wheel that I'm having, it is showing here 0 degrees. Here is 180 degrees. Okay, so it is adding 10 to 90 to 180, but it is reversing. Okay, so depends on your degree wheel that you are having. So if you guys are having the 0 to 90, but here is still 0 to 90, right? So this one you have to think of what is the top dead center, what is the bottom dead center, and you have to be very clear with your degree wheel first, and you can apply this method very easy. Alright? Alright, so I'm going to continue about the exhaust. Okay, I'm going to draw it with a blue pen. Okay, exhaust opens before bottom dead center. Okay, that means the exhaust valve is starting to open before the pistons reaches the bottom dead center. That means it is still on the power stroke. Okay, maybe it is finished burning already, so there is no more power. So during that time, the exhaust valve opens and it allows the exhaust gas to escape earlier, and more can be. If more exhaust gas can be escaped, that means more cleaner air can come in. Alright, so let us draw some 51 degrees before bottom dead center. It is around here, roughly. Alright, exhaust open. Okay, 51 degrees before bottom dead center. Okay, is it clear? Then the closing one is exhaust close before top dead center. Okay, so around here. Okay, exhaust close. Okay, this one the front word is before. Okay, so just have to use our logic. The middle should be around here, right? Can you see the exhaust close is around here, the exhaust open is around here. So the middle should be around here because it is open all the way to here. So the middle should be around here. Okay, let's do some calculation. It's very easy. Okay, so we need to add this plus this. So this is 51 degrees. Okay, plus how much is here? 5 degrees before top dead center. That means the whole thing is 180 degrees. It is 5 degrees before the top dead center. That means here is 175. Okay, that means it is 180 minus the 5 degrees. 175. So 175 plus 251, it is 226. Is it correct? Yes. Okay. So where is the middle of 226? 226 divided by 2 is 113 degrees. Okay, so what is this 113 degree means? That means after here 113 degrees or before here 113 degrees, it is at the center line. How I'm going to calculate that is very easy. I just use here is 5, I just add 113 because because that way I will get my center line. 113 becomes 116. So when it is showing it here, blue color, 116, this one is the center line for the exhaust at 116 degree. Okay. The center line for the intake is 110. Okay. So it should be 116 degree before top dead center. Okay, can you see this one is your top dead center before the top dead center. Alright, so this is after you calculation. After you calculate this, then you can move on to your third step. Okay, your third step is you have to set up all your dial indicator on your cam. After you setting it up, after you set up your degree wheel, you find the true top dead center. Okay, so you need to do 2 steps.
The first step is you have to make sure that your degree wheel is exactly 0 degrees when the piston is totally at top dead center. Okay, so how do I do that is I put a dial gauge onto the first cylinder, and then I'm going to check, and then I'm going to touch on the surface of the piston. So when the dial indicator it was depressed, it was pressed, but when the piston moves down, then the indicator will go down. Okay, so this part is the top dead center, so I'm going to show you guys. Okay, so I already set up my magnetic clamp, and then I also set up my dial indicator pushing at the bottom. So I'm going to rotate my crankshaft. Okay. Can you see when it bounces back? That means the piston is going down already. So what I do is I need to make sure where is the 0 degree. Okay. Okay, here's a 0 degree. It's a bit over, I'm going to redo again. Okay, so here is the top dead center. Okay, I'm going to change my degree wheel. I put this pointer directly on top of it. Okay guys, so the second step is to make sure that your cams are set correctly to your manufacturer cam card. Okay, so what I'm having here is I'm using this PC Brian Crower 264 cams, and then I'm going to share with you guys the cam card. I've already set up the dial indicator for the first valve, and then this one is quite tricky, so you have to be careful. So what is important, first you have to make a plate so that it can secure the magnet, and then this magnetic holder is going to hold this dial indicator. Okay, this dial indicator have to be very careful. It has to be this dial indicator must be perpendicularly touching on the surface of the valve tappet. Alright, so this one has to be perpendicular so that you won't be pointing it like in an angle, and then you very hard to know that the exact lift, because it is a triangle already. The distance is you have to use Pythagoras theorem in 3D, so we don't do that. What we do is we try to make as perpendicular as possible, directly touching onto the valve bucket, or we call it valve tappet. We also have to avoid the cams from touching these two, so we have to be very careful. And then we try to depress the whole dial indicator into the valve tappet, so that when this cam pressing down, it can release, it can slowly go down. So this is what we do. Okay, after we have put this, we have to set this one as to 0.
Alright, then you find your true center line. Okay, this one I use a method that can be applied to any engines and any angle of your dial indicator, including the error too, no problem. Okay, so this is the method that I use. When the valve starts to open, the dial indicator shows a certain number, for example X. For example, you can set it as 1 millimeter, no problem, 1 millimeter of opening. Then you read the degree wheel. Okay, after you reading the degree wheel, you write it down. For example, it can be for intake, it can be 3 degrees, for example. Okay, because it has opened for 1 mm. Alright, so then you turn your crankshaft, turn until you reach the valve closing at the dial indicator 1 mm2. Then you read your degree wheel. For example, it is okay. Let's make it easier. Okay, 37 degrees. Okay, bottom dead center. Okay, let me give you another example later. Alright, so 37 degrees. So why these two magic number? Because I've done some calculation here. Is the middle of these two is still 110 degrees after top dead center. Okay, how do I do this? Okay, it is 3 degree. Okay, here, and intake close at 37 degrees. So the middle is, you have to do the calculation. Let me show you guys from this degree wheel. Okay, so for example, the valve opening, okay, the valve opening at 1 millimeters, it is at 3 degrees after top dead center. Alright, so the dial indicator closes at 1 millimeters. Okay, when the valve close at 1 millimeter before fully closed. Alright, so it is at 37 degrees. Here is 180, 30, 37 for example here. This one is intake close, 37 degrees. Okay, after bottom dead center. This one is after top dead center. Okay, so the total degrees is, here is 37. You have to, here is 37, here you have to add 180 until here, so you minus 3. Can you see the reasoning behind this? Then you divide by 2, then you can get around here. Okay, so the total is 37 plus 180 degrees minus 3. Then you will get 214. Okay, let's find the middle of the 214 is 214 divided by 2 is 107. Okay, so 107 means here I just add 107 and then I can get the center line of this cam. So exactly 110. So I use this to match with the correct cam cut. Okay, so if it is at, let's say, 4 degrees, it is at 38. Okay, I purposely add 1 to both of them. Then so what you can get is still 214. Okay, so should be like this. Minus 4. This one is 38. Okay, then you still can get 214. 214 divided by 2 is 107. But if you add from here, add from the 4 degrees to the 107, okay, then you should get 111 degrees. Okay, so what you need to do is you make adjustments on your cam gear so that you can get 1 degree lower.
Okay guys, there is one more tip for you guys is this timing belt. And most of the engines, all of the engines are turning clockwise direction when we are facing this, facing the engine. So what we do is when we turn the crankshaft, we have to turn it clockwise. But if we have to turn it counterclockwise, yes, you can do that, but you have to go over to the degree that you want and come back again. Why we do that is because we have to tighten this direction of the timing belt so that this one is every time constantly tighten. Let's do this. The first one is 0 degree after top dead center. What I'm using is this SATA handy tools. This SATA are not very cheap, but it has lifetime warranty, so I'm very happy to use it. Okay, remember one more tip is try to release and try to tighten these bolts with the old-fashioned star pattern. Alright, star pattern. Okay, so that the pressure is distributed evenly. Okay, for all your tires, you also have to do that too. Use 17 millimeters. Move this one until I can reach.
Okay, keep on doing that and do triple checks until you get the correct cam timing and repeat for the exhaust cam. So this is the easy way and the proper way, error-free, to do your cam dialing.
Okay guys, I'm going to tell you guys one more mistake that I've done. Okay, is this dial indicator I already used the maximum travel. So this is not what we want to do. What we want to do is we need to release it. Okay, we don't use the maximum travel, but we slightly let go of it. Slightly let go of it. Because this is the maximum travel, we are going to slightly let go of it. Okay. We're going to reset again, and I'm going to share with you guys what do I do just now. Okay guys, press the like button if you guys like this video, and share with your friends if you think this video will benefit them. Subscribe for more videos, and I will share more insights of 2JZ engine building. See you!